Hi, this is the replacement of every cell from vacuum cleaner. It's model Bosch. As you can see, here is the chip BQ77. This is the main chip and this is the board, and I need to remove all the 7 cells and replace every cell because these cells are very old and they are not doing well. There is no power for the vacuum cleaner. I need to remove this with hot air. I'm using hot air to remove this white piece of paper, this adhesive, and after that I need to desolder. I need to desolder every pin of the BMS. Here, here, and here. These all 7 cells are in series and I need to make the new connection for them. As you can see, there are Samsung cells and I'm using compatible cells and much more power and more capacity. This is the only way to remove this paper with hot air. Be careful not to touch any the cells. Now the BMS is disconnected from here, and now they need to be removed from here, and after we'll resolder with a special solder, puncture solder, and internal code. This is the internal code. I didn't desolder these 2 wires. Now I'm using my marker to mark this. So here it goes minus, plus, minus, plus, minus. Here is some minus, some plus, minus. So the minus, and here is a plus. Also the main connector with 25 volts. So when this is done, I can remove all the wires. But first of all, I want to remove this one. This is the main connector of the PCB. There is hot voltage here, and I don't want to mess with the board. 26 volts are here, and I will remove this battery minus once I have this hotted, and I will remove the negative wire, only one of, and maybe cold, must increase the temperature degrees for how long. I reached the cell and now I have to desolder this carefully. If I want to reuse it, I will reuse this piece of metal. I don't know. I have to find first if it's suitable for reusing, or maybe solder and wire new nickel around here. Maybe it can be reused, but it's a sign of using, sign of marks. And I now have to deal with every single piece. The final procedure, it is this is how it looks without cells. And now I have to put another cells and I have to spot weld. I have to weld with my spot welder. This is how it is done. I will bring my new cells. Hello, now I am continuing my review. I have found cells. These are lithium-ion cells, and you can find with this code, cell code, it marks out. As I said before, you need to put every cell in balance, in perfect balance, voltage balance. So I have here the 7 cells put in parallel mode, so I can check each voltage. It must be the same at every cell, every single cell. They have to be in perfect balance. So after you charge and you balance, you can proceed with putting in the back in here, and if the voltage is equals between that every cells, this is a handmade balancer. Every plus and every minus from every cell is common, so plus is here, minus is here. And now, as you can see in here, I have tested every cell, and it has 2845 milliamps, 2.8 amps hour. These are very good cells with 20 amps discharge, max 20 amps discharge, and continuous is 15. So now I'm putting back here and reattach these wires, and I have to spot weld every single cell. I have marked here plus minus, so I will not be mess this data. As you can see, here is the sensor, temperature sensor on first cell, and I have to put it right here, but first of all, you have to install protect caps. These are protect caps for every cell to not damage when you spot welder. And if you install in this way, there is no danger in here, not at all. So every cell must have this protective cap. I have here only 6. I must go the middle remains in here, and I use only this circle to install it this way. You cannot go wrong with this. And I show you my spot welder, and this one over here I have to bring another foil. This is used and it has to go at garbage. Here is the new cape caps, and and the cells are fine right now. And I will go with regular. Let's put this. It has this little from here, so now it's protected. And this is minus, this is plus, and this is minus. This is plus, this is minus, this is plus. It's better. These are the new cells which I have to resolder. Let me check with this board. It goes right here. Yes, very fine. This way, of course. And now only thing I have to do is to reconnect this and proper. I have this spot welder from Mind RC DH30 Max V2, and I have to set it around gear 10, waiting time 0.4 seconds, and I have 2 pieces of solder. And I have I'm using this type of nickel around 2 millimeters. So I have to put from here to here, and in the middle it goes this little wire for the BMS. Before I'm going to spot weld, I have to do one little test to see. Well, this is not good. I don't know where this go. Here it is. Okay, now I have to make a little test. I'm ready for the test. I'm putting 2 spots and see how it goes. It needs more power to go on 15. Now I'm trying. This is too much. Not okay. Still not okay. Go 20 and see how it goes. Not good. Not penetrating this much power. It has too much power. Let me give another try. It stays is okay in third speed, 13 gear, and now solder. It's melting very, but I have to be sure. I will make another test in here. Let me see. The spot welder very fine. Maybe in the 10 gear and not more, not so pressure. Good enough, but not good for me. Let me try another test, use another cell. I'm confident here. This is doing well. 12. Let me try with 12. And I have to clear these pins because they're feeling so sticky, and I don't like this. Let me try this spot welder between two bands. You have to put something under these two about metal. You don't have to solder here on the plastic because the temperature is too high. It might get burnt. See, spot welded. Very, very nice. Very good weld. This is 0.1 and this is 0.2 thickness. With more thickness you get more amps. Less thickness you get less amps and power loss. And I will use this strong metal to get more amps, of course. First spot weld. I hope very good weld. And I have to continue about the second cells. The minus is here and the plus is here. Let me check again. This is plus and here is the minus. So it's okay. No heat to the cell and very good weld. And now I have to put one more here. Perfect. 4 spots of welding. And now you have to be very careful to not spot these two again. You will make a short circuit, and you will be burned. So be very careful when you weld these cells about the high current. As you can see in here, I'm just using my last cell. This is my last cell because I lost one of the cell at my spot welder. My spot welder punctured the cell, and now I'm using another cell because you can't use not very good cells. It must be in perfect shape because they are high current cells and must be working for long time. So I'm installing the new cell right in the 7 place. As you can see in here, I'm using my protective caps and installing protective caps on the top of the cell with the plus not touching the ground. Minus is on the rest of the cell and the plus is the top of the cell. And as you can see here I have to spot weld these two cells, plus with minus, and I'm setting my spot welder. This is a Minder XC model, very high current model. I've used it in the past 2 points of solder I'm not saying solder. As you can see here, I'm cutting the table strip. I'm cutting with special tools, and I'm preparing now to spot welder between the last 2 cells. I'm preparing the nickel plate, put around the 2 cells and fix it to hold tight. Now I'm preparing my spot welder. Because of the short cables, I have to put in convenient position to reach out at cells. And now I'm spot welder first cell, 2 points and another 2 points. As you can see, you can hear a sound, a beep, a short beep. Now I'm preparing the minus of the last cell. Hold not tight, not too much pressure, because you can put much pressure, the weld is not well done. 2 points again, and the nickel strip is very good soldered. And now the last connection with the plus and the minus of the PCB mainboard. The PCB mainboard, it has 2 wires, plus and minus, and I have to cut down I have to cut down to make a good connection. As you can see in here, I'm cutting down plus wire to connect with the battery, and after I'm cutting the minus wire. Now I'm placing my board on the vacuum and to hold and preparing the spot weld, the plus of the battery. I'm making the last adjustment to fit right in the place. I have to cut a little more, around 8 millimeters, because my nickel plate has 8 millimeters wide. Now I'm measuring the nickel strip to fit perfectly in the position. I'm now soldering. You have to put some metal between under the plates. You have to spot weld on some metal, because you can melt any plastic or any material under the spot welder. As you can see, now it's done. It's not perfectly aligned, but it's punctured. Be careful, because the weld is very hot, and your skin might get burned. Final cut around the nickel strip, positioning with. Now I'm positioning with the place in the right place and preparing for spot welding. The final spot weld, 2 points, and now the last 2 points. I'm checking the physical connection to be strong and not to move from the place. And now I'm arranging the minus of the battery pack and cut it on the right. I'm cutting the right amount of length, around 8 millimeters wide, the same with the nickel strip, as you can see in here. I'm cutting around 8 millimeters wide, as I said before, and now I'm positioning the 2 plates for spot welding. I hope it will be a very good weld. Spot weld right here, 2 points. I think the plates were moved from the initial position, so I have to increase the pressure for spot welding. They are not, as you can see, they are not weld, and now I have to retake the spot welding. I'm cutting the nickel plate around for the right length and redo the spot welding. Minus. I'm checking the spot welder. I'm checking the spot welded. I must apply another weld to make a good and a perfect contact. You can weld one side, 2 sides, and more than 2 points, and check if this is a good weld. Weld again, and I think this is the last one. As I said, more pressure you apply, more current you have to put in the pins. Less pressure, more heat will be around the plate. Pressure again, you can see the two sparks. This is an automatic spot welder, it doesn't have the pedal, and now it's already in the place. And in the final, I have to solder the BMS wires. They are 7 wires, I think they are 7 wires, and it needs to be soldered on the nickel plates. It's a long process, and you have to be careful not to touch anything with your iron, not to make a short circuit, and please be very careful when you spot welder, or this might be a very dangerous project. But if you are done it before, there will be no problems. Now I'm soldering points for the nickel plate for the BMS wires, starting the first wire, and then each wire must be soldered in the same place. Now I'm soldering the second wire, and so on with the top wires. You can solder in any right direction, in any direction. Just be careful not to touch between the terminals and not to do a short circuit. And now, as you can see, the board is turned upside down to solder the last connections. To make a good connection, you have to clean the area and then solder with flux. Each tweak connection between the cells, the battery cells, it must be connected to a BMS, and the BMS will adjust current for every cell, not to remain balanced with voltage. Placing the wire very carefully for the welding spot, for the soldering spot. Each wire must be placed exactly as before, and make sure it has a very good connection. It's important for the BMS to control each cell with the right voltage. Route every BMS wire to be in the good place, because this might get some vibration. The motor is a very spin motor, it has high RPMs, and make sure this wire will not get loose in the place. When you reach it at the last connection, the minus, place it around 19 degrees in the right angle with the cell. Make sure you are welding. Make sure the welding is perfect, not too tight and not too loose. Too loose, the cell might be punctured, and too loose, it has a weak contact. Spot welder here, and 2 points, and spot welder again, 2 points. And if you are not sure of the weld, you can apply more 2 points of welding. And now it's finished. Let's measure these points. I think the measure voltage, it will be around 29 volts. 29 volts, and very important, before you can plug the BMS wire, it is better to measure each cable to put in the right way. The right way means the voltage will increase with every single cell. After I measured every wire of the BMS, I can installing back to the PCB board, back to the PCB, and then I will check the wires to be in the same place before I started this procedure. Now the wires are lined up and held in place with Kapton tape. And the final step is to put back the protective band, this protective band back on the cells. This band will prevent the cells from making contacts with, maybe accidentally touch with metal parts. There is no metal part in here, but is the motor. The motor is very high spinning speed, and the battery and every cable must be remain in its place. I'm with the hot gun. The hot gun reactivates the adhesive. The adhesive in the temperature, in high temperature, will become adhesive again. The adhesive will stay in the contact with the metal surface, and it remains in this position if you apply some hot air. Do the same with the rest of the adhesive material. In the bottom layer, put the adhesive in his right place, press on it, and then blow some hot air to replace in the final position. Here I'm using my hot air gun, to reattach this protective band. And now I am the final step to make the last checks with this protective tape, and will assure the wires will not move from its place. And that's it. Now I will perform the last test with the motor connected. The motor is very simple. It has two wires, middle and high. As you can see, I'm recording right now the test with the motor connected, and it's very loud. This is the first speed, the second speed, and the last speed, the most of it.